Hey class, this is Mr. Win, here with a video on 17.2. This lesson is going to start off with a Desmos activity actually, and then from there we'll do just a little bit more in the textbook. So starting with this Desmos, this is going to help us connect something that's called a linear function with their products. We actually know what a linear function is, and the product is going to be a quadratic function. So let's dive in. Right here it's asking us to create a linear equation in line 2. Okay, here's line 2. And another linear equation in line 3. So you can come up with any linear equation that you can think of. Let's just do x plus 2. Okay. Here's my line y equals x plus 2. Okay, it wants us to come up with another one, so let's just come up with something random. What about y equals x minus 3? Okay, I just created two lines. The blue one is y equals x plus 2. The green one is y equals x minus 3. Alright, now it says write the product of the two linear functions in line 5. It's talking about in this line, writing it like in the code here. So we're going to write the product of the linear functions. What it's asking is, here's my blue function, it was x plus 2. And then here's my green function, it was x minus 3. Notice that when you multiply two linear functions together, this is my red graph, this gave me a quadratic function. Okay, pretty cool. So a linear function times a linear function gives me a quadratic. Alright, and you can go through investigation number 2, do the same thing, come up with your own two linear equations. Let me just do one more here. So let's be a bit more creative. So maybe we'll do negative 2x, and then I'll do y equals, let's see, what about 0.5 x minus 4, or something like that. Okay, now we want to write the product again. So my blue function was negative 2x, my green one is 0.5x minus 4. Here we do have a quadratic. If I zoom out, you'll see it like that. Okay, and you can do a third one also. Try a y-intercept that is negative or 0. I'll just put in y equals x, y equals x minus 2. Okay, let me just put in 1 here so that it pops up. Okay, this is on investigation 3. Yeah, okay, good, it pops up there. Okay, describe the relationship between the x-intercepts of the two linear functions and the x-intercept of the product of the linear functions. Why do you think this relationship makes sense? So notice on our blue graph, my x-intercept is, so on the x-axis, the part that I'm crossing is 0. So my x-intercept there is 0, or really 0, 0. My green linear function, my x-intercept, turned out to be, I think that's 2. Okay, so the point 2, 0. Now on my red quadratic, let's look at my x-intercepts. I have 2 of them. There's 2 places where it crosses the x-axis. Crosses right here, actually the same place that the blue graph crosses. And it crosses where the green graph also crosses there. So my x-intercepts actually is 0, 0, and it's also 2, 0. So notice that the two linear factors, the two linear equations that we multiply together, each of their x-intercepts are part of the x-intercepts for the quadratic when you multiply them together. Okay, let's look at the relationship between the y-intercepts. So on my blue graph, my y-intercept is 0, 0. On the green graph, my y-intercept is, let's see, looks like negative 2. So 0, negative 2. And on my red graph, my quadratic function, again, we're multiplying the two linear factors. It turns out my y-intercept here is 0. 0, 0. Okay. Let's let me change this a little bit just to see. Actually, let's look at a different one. Let's look at my investigation number 1. Okay, so on this one, let's look at the y-intercepts. Y-intercept here is 2. Y-intercept here is -3. The y-intercept on my quadratic is -6. Let's look at the relationship 2, -3, and -6. Well, 2 times -3 is -6. So maybe that's the relationship. Let's look at investigation 2. We had -0, sorry, not -0. 0 here, -4 here. On my red, it's 0. So maybe on the blue graph, 0 times the green graph times the green, 0 times -4 is 0, so maybe that works. And on the last one, we also had 0 on the blue, -2 on the green, and then 0 on the red. So we can hypothesize that our y-intercept for the quadratic function, perhaps it's multiplying the y-intercepts of the two linear equations, and that turns out to be true. Okay. So again, the x-intercepts, you have two linear equations. Two linear equations means two x-intercepts. Those are the same x-intercepts on the quadratic. Again, we got that quadratic by multiplying together those two functions. And then over here, for the y-intercepts, it turns out if we multiply the y value of the y-intercepts together, we get the y value of our quadratic. So let's try to figure out if we can find two linear factors that when multiplied are going to give us the parabola here. So we said we want the x-intercepts to be the same. That means I need a line that goes through here. Here at the point -4, 0. And I want a line that goes through this point 2, 0. So let's focus on -4, 0. Let's see, y equals x is not going to do it. I need to go over some amount, so let's see, -4. No, I need to go the other way, so let's do +4. There we go. Now I got a linear equation there. I want one that goes through the point 2, 0. Y equals x plus 2. That's not quite it. I got to go the other direction. Let's do -2. There we go. So we got -4, 0. Went through there. That's our x-intercept. X-intercept here. So let's see if we multiply these together, if that gives us our quadratic. Okay, times x minus 2. And you can see there, this graph is also in red, so it's kind of hard to see, but if I click off, here's the original, here's a new one, it kind of overlaid on there. So it turns out I picked the right ones that multiply together to make that quadratic. Okay, now we're in the textbook, 17.2. And we're going to see how that connects to this lesson. So we're going to skip this first page, and we're going to go here. So a quadratic function is in factored form when it can be written like this. Y equals k times x minus a times x minus b, where k is not equal to 0. Because if k was 0, 0 times this is 0 times this is 0. The whole thing would be 0. We just need k to be some number. So x minus a times x minus b, basically. Again, this is called factored form. Okay, it's called factored form because we have two factors. Really 3 if you count k, but mainly those two. Now, just a quick review. Now we have 3 types of forms. The first form we learned about was standard form. Standard form looks like this, ax squared plus bx plus c. Then we learned about vertex form. Vertex form is a times x minus h squared plus k. Remember, from vertex form you get your vertex, h and k. And then now we just learned about factored form. Factored form is something like x minus a times x minus b, maybe with the k out in front. So those are the three forms of quadratic equations. Okay. So factored form, let's see. We can change an equation from factored form into standard form. The way we do that is what they did over here. They just multiplied it out, basically. So let's do part B. I'm just going to multiply these two factors together. And so how I'm going to do that is, it really just wants you to rewrite the problem right here. X minus 5, x minus 2. I got a binomial times a binomial, so I'm going to do the FOIL method. Right, so first, outer, inner, last. So I'm going to do x times x, gets me x squared. I'm going to do x times negative 2, negative 2x. Let's do negative 5 times x minus 5x, and then last combination, negative 5 times negative 2, negative 10, sorry, positive 10. If you got confused on that, make sure to review how to do the FOIL method, how to distribute. Okay, so we want to multiply the resulting trinomial by 3. So I need to simplify it. So this is x squared minus 7x plus 10. Okay, same thing. I'm going to distribute this 3 into each term. So I got 3x squared minus 21x plus 30. And so my standard form is just that, 3x squared minus 21x plus 30, and I should really put a y equals over here. So that's how we change from factored form into standard form. We actually know how to change from standard form into factored form. The way we do that, and we're not going to focus too much on it here, but we've done it before, what we would have to do is we need to factor this trinomial. Okay, so that's factored form. You can do problems 5 and 6, that'll be good practice. Here, just remember that the x-intercepts of the graph are the same thing as our zeros. Okay, we learned that last lesson. We call them zeros. Okay. And let's skip over here. If we have the x-intercepts of a quadratic function, we can write the function. So here, let's look at, we'll actually get to that next lesson. Over here, let's look at example A, example 3, part A. If we're given the x-intercepts 2 and 5, I'll just let you know now that that means I need a linear equation where the x-intercept is 2 and a linear equation where your x-intercept is 5. So x minus 2 and x minus 5, those are going to work for us. And then if it tells us my k value is 1, my k value is 1 right there. Okay. And I think I'll actually save that a bit more for the next lesson. So don't worry too much about that right now. For now, just make sure you know 2 linear functions. Okay, x minus 2 is a linear function, or sorry, linear factor. Okay, 2 linear factors multiplied together gives you a quadratic equation, and the x-intercepts of those two linear factors are the same. Those are going to be the x-intercepts of your quadratic as well. Alright, that's going to be it for this one. Have a good one, and think win-win.